So when we look at colorblindness as inherited as a sex-linked recessive trait, what we do, so we can think about dominant and recessive like normal. So here you would have the capital B would still represent C's like all colors, so not colorblind. And then here you would have colorblind would be recessive. However, because it is a sex-linked trait, it's going to be different how it's inherited compared to autosomal. If this was autosomal, then every person would have 2 copies, like this. However, because it's sex-linked, most of the time when we see sex-linked, that implies that it's on an X chromosome. The X chromosome has about 1,000 genes, whereas the Y has only 30. So if we talk about a female who can see all colors, well, to see all colors would normally be these 2 options. So here, you would write the B's on the X's like this, and that lets us know it's a sex-linked trait. So a male who can see all colors, now a male only gets 1 copy of sex-linked traits because they only have 1 sex or X chromosome. So a male who can see all colors would have this genotype, whereas a female who is colorblind, you would write her genotype like this, and then a male who is colorblind, he only gets 1 copy. And so for guys, if they inherit the dominant allele, they're going to have the dominant phenotype. If they inherit the recessive allele, they're going to have the recessive phenotype because they only get 1 copy. And this is how sex-linked is different than autosomal inheritance. So the question continues, complete a Punnett square between a colorblind female, so that's this female here, crossed with a male who can see all colors. What is the probability of having a colorblind son? So now, I recommend when doing these Punnett squares of writing your boxes a little bigger. So with this here, we'd put our female, and then here's the male. And as we fill these in, we see that both of our females are going to be able to see all colors thanks to the allele they inherited from their father. And then for males, males get their X's from their moms, and they get their Y's from their dads. So here, this male is going to be colorblind, and this male is going to be colorblind. So when I ask, what is the probability of having a colorblind son? 2 out of 4. There's a 50% chance their child will be colorblind. I mean, their son will be colorblind. If the question asked the likelihood of having a daughter who is colorblind, it'd be 0%. These 2 parents cannot make a colorblind daughter.